So in 2022, the Nobel Prize in Physics was given to Alan Aspect, John Clauser, and Anton Zeilinger. And the prize was given for other things, including violation of Bell inequalities. So a question that comes to mind, that what is a Bell inequality or Bell game, and it has become very popular recently after the Nobel Prize in 2022 was given to this gentleman. So in this video, we will try to understand what is a Bell game or inequality. So let's try to see what is a Bell game. Actually, to understand what is a Bell game, you don't need to understand quantum theory, because Bell game can be formulated without any reference to quantum theory. It's just plain language, like simple classical theory formulation, where there is a referee and there are two parties, Alice and Bob. So in the Bell game, there are these two parties, Alice and Bob. They are not supposed to communicate. They are not supposed to communicate once the game has started. Before the game has started, they can talk as much as possible. They can agree on a strategy, how to win the game, and so on. But once the game has started, they cannot talk to each other. Also, before the game has started, they can share any randomness or any resource that they want among themselves. But once the game has started, they are not supposed to communicate. That's very important. So we have this referee, and the referee asks questions to Alice and Bob. So the referee asks question X to Alice and Y to Bob, and Alice responds with A and Bob responds with B. Now this X, Y, A and B, they are in 0, 1. So they can be either 0 or 1. Now verifier or referee, when they get the A and B, the responses from Alice and Bob, they check whether X dot Y is equal to A plus B. So this is what they check. Now if this condition is satisfied, then they say that they have passed the test, or they have won the game. On the other hand, if this condition is not satisfied, then they have lost or failed the test. Okay. So basically they can do many iterations of this question answer thing, and in classical theory we know that they can win at most 3/4 of the time. So let's try to see how do we get this number 3/4 using a very simple argument. There is a more involved argument and proof, but we won't go into that detail. So to understand that, let's see the situation here. So we have been given here X, Y, and we have to come up with like A plus some value of A such that X dot Y is equal to A plus B. So let's see, X is equal to 0 and Y is equal to 0, or X can be 0 or Y can be 1, or X can be 1 and Y can be 0, or X can be 1 and Y can be 1. Now when X is equal to 0 and Y is equal to 0, A plus B has to be equal to 0, because X is 0, Y is 0 and 0 dot 0 is 0. So A plus B has to be 0. So this has to be 0. Similarly, when X is equal to 0 and Y is equal to 1, X dot Y is again 0, because 0 dot 1 is 0. So A plus B has to be 0. When X is equal to 1 and Y is equal to 0, in that case also X dot Y is equal to 0, and hence A plus B has to be 0. On the other hand, when X is equal to 1 and Y is equal to 1, then X dot Y, in that case X dot Y, because this is 1 and 1 dot 1 is 1. So basically the a plus b has to be equal to 1. Notice that, like when I do here plus, when I write here plus, it's basically modulo 2 addition. That's what we are talking about. Now notice that when is a plus b equal to 0 and when is a plus b equal to 1? A plus b is 0 only when a and b are same. So in this case a and b are same. In this case also a and b are same. In this case a and b are same. On the other hand, when a plus b is 1, then a and b has to be different. Now 3 out of 4 times they have to be same, and 1 out of 4 times they have to be different. Now, no matter what a strategy they come up with, let's say they agree on the strategy that no matter what is the question, we will always output 0, 0. In this case, they will win 3 out of 4 times. But because they are not communicating, because Alice does not know what question Bob got, Bob does not know what question Alice got, they cannot win all cases. And you see there that in actually 3 out of 4 cases is the best they can do. There is a more involved argument using probabilities and randomness and so on, but you got the essence that in regular classical theory, the classical world that we think of, they can only win 3 out of 4 times. Now let's look at like what quantum theory can do. Quantum theory gives you more resources. Quantum theory gives you more possibilities. In quantum case, Alice and Bob, they can share some entangled state. They can share some entangled state. So they can share this state 0, 0 plus 1, 1 by root 2. So this is also called a Bell state. So they can share it. And depending on the question that they get, so depending on the questions that they get, they choose to measure their copy of the Bell state, their copy of this entangled state in a particular basis. In a particular basis, they just measure it. So when x is equal to 0, they just measure corresponding to this basis, which corresponds to theta equal to 0. When y equal to 1, just put here theta equal to minus pi by 8. When x equal to 1, just put here theta pi by 4. When y equal to 0, just put here theta equal to pi by 8. Now in this case, if you do a detailed calculation, you will find that they can win cos with probability cos square pi by 8, which is approximately 85%. This is interesting because you see that here they can win only up to probability 75%. So in classical world, they can win up to probability 7, they can win up 75 with probability 0.75 or 75%. In quantum case, they can win up to 85%. Now, there is this gap between quantum and classical, like this quantum theory can do more than classical theory, which proves that the quantum theory is a non-classical theory. And because we can do this experiment in our world, this proves that the world that we are living in is actually a non-classical world. It's a quantum world. So that's what it proves, that it's a non-classical world. That's what we know. Whether it's a quantum world or not, one can debate about that. But at least this proves that the world that we are living in is actually a non-classical world. And that's why this thing deserves the Nobel Prize. So far I talked about a game formulation, but there is inequality formulation also, where like in classical world, you can, according to classical theory, you should get value up to 2, but in quantum case we can get up to 2 root 2. And since 2 root 2 is greater than 2, it proves that the world that we are living in is actually a non-classical world. Actually, the game formulation and inequality formulations are equivalent, but that requires some mathematical calculation to show, like how they are equivalent, and maybe I will cover that in some other video. Also notice that the Bell game or the Bell inequality that I was talking about is CHSH inequality. So the CHSH inequality is has closure horn Simony Holt, and the closer of CHSH was one of the people who got the Nobel Prize. So that sums up what is a bell game or inequality for you. If you are interested in this kind of content in general about technology and science, please, I would say, spread the word around. And if you like it, then just I would suggest that please subscribe to the channel. Thanks for watching. See you in the next video.